And we're on example 5, and we have r squared equals 36 cosine 2 pi. So we are going to find the maximum r values. So it's a cosine 2 pi. So wherever there's a cosine 2 pi, we'll put in first -1 and then 1. So we'll take the absolute value of r, and we'll say it's the square root. Oh, so we're going to solve for r. So r is the square root of 36 cosine 2 theta. Okay, and so when we put that in there and we put a -1 in, we get d and e because you can't have negative under the square root. So we take r and we put a +1 in for cosine 2 theta, and we get square root of 36, or the absolute value of 6. So we know that the biggest r will be a 6. Now let's find where it is. So we'll put 6 in for r, and we get 36 cosine 2 theta equals 36, squaring r, right? And we get cosine 2 theta equals 1. So we know that that 2 theta, if, like, what angle gives us 1, what cosine angle gives us 1, 0 does. But we have to go to 4 theta, because it's a cosine of 2 theta, so we have to multiply our 2 pi times 2 to get how far out we need to go. So we go to 2 pi, it's 1 at 0, it's 1 at 2 pi, and it's 1 at 4 pi. And so we have theta, if we divide by 2, is 0, 2 pi over 2 is pi, and 4 pi over 2 is 2 pi. So we know that r, the absolute value of r, is equal to 6 at 0, pi, and 2 pi is kind of itself again, that's 0 again. So we can just say at 0 at pi if we wanted. So we know that we have 0, 6, so I know this point already, and I know that I have pi 6 too. I might not need it, but I know I have it. So that's why I don't do the points till the end, because I don't know about symmetry and stuff. So next thing I find out is the zeros. That's down here. 0 is 36 cosine 2 theta. So where is cosine equal to 0? It's equal to 0 at pi over 2 and 3 pi over 2, but we have to keep going because it's 2 theta, so I have to go all the way up to 4 pi. So that'd be 5 pi over 2 and 7 pi over 2. Then I have to divide each of those by 2, so I get pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So I have a bunch of zeros. I have 4 zeros, and I don't know if I'll need them all, but that's what I know I'm going to have if I went all the way around the unit circle. Now let's try symmetry. Symmetry. Is it symmetric to, it's a cosine, so is it symmetric to the polar axis? And the answer is yes. Okay, that was an easy one. Putting in r negative theta would give us the same thing. But I also want to see, because of this r squared, I'm pretty sure, right, that it'll be symmetric to the pole. So let's put in the pole is negative r theta, and if I just square r squared again, it will give me the same thing. So it's symmetric to the pole. And just on a whim, hey, let's see, is it symmetric to the polar axis? If it's symmetric to theta over 2, if it's symmetric to the polar axis and the pole, it's probably symmetric to all three. So sure enough, if I put in negative r negative theta, I get a yes. So it has all three kinds of symmetry. So that's pretty cool. I can draw symmetry down theta equals pi over 2, and I can draw symmetry at the polar axis. And it also has symmetry at the origin here. Okay, so that's nice to know. Definitely only have to do the first quadrant then. So we already know at 0 is 6. So I have a point, this is 6 out here, I guess. So I have a point at 0, 6. At pi over 12, it became 5.6. So here's pi over 12 on my graph in orange now, and that means symmetry-wise, across the polar axis, I can put one down there in quadrant 4, and across theta equals pi over 2, I can put one right here I'm over here in the second quadrant. And because I have one in the second quadrant, I can put one in the third quadrant. Oh, and don't forget, symmetry across the theta equals pi over 2 would give you this point here also. So I have 3 on each side now. At pi over 6, I'm at 4.2. So I'll get 4 points out of there, that one across that axis, flip it there, and back over here. And at pi over 4, it goes down to 0. So I know I have 2 petals here and here. And because of symmetry, well, if you went on, you would get undefined because these will all have negative under the square root. So that's your graph for number 5. And that's the notes for this section, not for the day, but just for this section. Because next we're going to talk about these shapes have names. You heard me call it a rose, a circle, so we're going to learn those. And they're not hard to learn, and that helps you the most because then you know what it's supposed to look like when you just look at the equation.